In the darkest reaches of our planet, far below the crashing waves and sunlit shallows, lies a region so mysterious that it remains one of the least explored places on Earth, the Hadal Zone. This abyssal realm, which begins at around 6,000 meters below sea level and stretches to the bottom of the deepest ocean trenches, has long captured the imagination of scientists and science fiction writers alike. It's a place of crushing pressures, frigid temperatures, and perpetual darkness. Yet, strangely, it is not marine biologists or oceanographers alone who are investing resources to uncover its secrets. NASA, an agency synonymous with space exploration and distant worlds, is now sending probes into this hostile underwater frontier. But why is a space agency so deeply invested in the Earth's most inaccessible ocean depths? The answer lies in the striking similarities between the Hadal Zone and some of the extreme environments found elsewhere in our solar system. NASA's growing interest in ocean worlds such as Europa, the icy moon of Jupiter, and Enceladus, a small moon orbiting Saturn, has made understanding Earth's deep oceans more urgent than ever before. Beneath the icy crusts of these alien worlds, vast subsurface oceans are believed to exist, hidden under miles of frozen surface. These oceans may not only harbor liquid water considered essential for life, but might also contain hydrothermal vents, similar to those found in Earth's deep seas, where life can thrive even in the absence of sunlight. To prepare for the day when a probe might penetrate the ice of Europa or fly through the geysers erupting from Enceladus, NASA must first master the art of exploring our own planet's most extreme aquatic environments. That is why probes like Orpheus and projects like Subsea are being developed not just to study Earth's oceanic trenches, but to serve as analog missions for future space exploration. These are test runs, dress rehearsals in a world that mimics the alien oceans NASA hopes to one day visit. The Hadal Zone, in all its mystery and hostility, is Earth's closest proxy to those far-off, ice-covered alien seas. But venturing into the Hadal Zone is no small feat. The immense pressure, over 1,100 times the atmospheric pressure at sea level, can easily crush conventional equipment. Temperatures hover just above freezing. Communication with the surface is difficult and slow, and a complete absence of light makes visual navigation extremely challenging. Any probe sent to this depth must be built with ruggedness, autonomy, and intelligence. It must be able to navigate unfamiliar terrain, withstand high pressure, and make decisions on its own without direct human control. In many ways, these are the very same requirements that a probe on Europa or Enceladus would face. Take, for instance, NASA's Orpheus, a compact, highly maneuverable robotic explorer designed to dive into the crushing depths of the Hadal trenches. Orpheus isn't just a scientific tool, it's a technological pathfinder. Its small size and AI-enhanced navigation system allow it to map the seafloor in stunning detail, much like a future Europa lander might survey an icy alien seabed. The data collected by Orpheus helps scientists understand the geology and biology of deep-sea environments. But equally importantly, it teaches engineers how to build more capable robots for interplanetary missions. Orpheus must operate independently for long durations, interpreting sensor data and making navigation choices without real-time human input, a vital skill for any robot venturing beyond Earth. In addition to Orpheus, the NASA Jet Propulsion Laboratory has partnered with other agencies in programs like the Systematic Underwater Biogeochemical Science and Exploration Analog, or Subsea. This initiative brings together experts in marine biology, geology, and robotic engineering to study hydrothermal vents on Earth's seafloor. These vents release mineral-rich, superheated water and form ecosystems that thrive without sunlight, relying instead on chemosynthesis, where organisms derive energy from chemicals rather than light. This is a groundbreaking discovery because similar hydrothermal vents might exist on alien ocean worlds, potentially serving as cradles of extraterrestrial life. What Subsea offers is more than just a deep dive into Earth's oceans. It's a unique opportunity to simulate the operational challenges of deep space missions in real time. Researchers use remote control ships, simulated communication delays, and robotic exploration tools to mimic how a mission might unfold on Europa or Titan. Every mission to the deep sea becomes a chance to refine strategies, test hardware, and sharpen protocols for space-based ocean exploration. It's a multi-layered learning experience that benefits both Earth sciences and space sciences simultaneously. And while the search for alien life may be the ultimate goal, the benefits of NASA's Hadal Zone expeditions extend far beyond astrobiology. These missions are producing detailed maps of the ocean floor, discovering new species, and expanding our understanding of Earth's geology. In fact, the Hadal Trenches are among the least understood parts of the planet, with unique ecosystems and geological formations that could hold clues to the Earth's past, including how continents move and how life adapts in extreme environments. These insights have profound implications for everything from climate science to biodiversity conservation. The potential to discover new life either here on Earth or on an alien world is a driving force behind much of NASA's investment in Hadal research. In 2019, researchers working in the Mariana Trench, the deepest known part of the ocean, found previously unknown microorganisms living in sediment samples. These extremophiles thrive in conditions previously thought to be uninhabitable, and they suggest that life is far more resilient and adaptable than we once believed. If life can survive in such hostile conditions here on Earth, it dramatically increases the likelihood that similar life could exist in other, equally extreme environments across the cosmos. But there's a deeper philosophical question woven into this effort. Before we reach out to other worlds, shouldn't we first understand our own? Earth's oceans remain one of the planet's last great frontiers. We have better maps of Mars and the Moon than we do of the Hadal Trenches. In seeking to understand alien oceans, NASA is also helping to uncover the mysteries of our home world. This dual benefit reinforces the agency's belief in unified exploration, where the same tools that search for alien life also help us better appreciate and protect our own biosphere. The challenges ahead remain significant. Building a probe that can survive for extended periods in the crushing depths of the Hadal Zone and autonomously perform complex scientific operations is a monumental task. And yet, each step forward, each descent into the abyss, brings us closer to one day reaching the alien oceans of Europa, Enceladus, or even Titan. The path to these distant seas begins right here on Earth, in the blackest waters of our own world. It's easy to think of space as the final frontier, but in many ways, the ocean's deepest regions are just as alien, just as unexplored, and just as important to our future. As NASA continues to bridge the gap between ocean and space, it reminds us that the search for life is a universal quest. Whether in the crushing blackness, beneath our waves, or beneath the icy crust of a distant moon, the urge to explore, to discover, and to understand is at the heart of what it means to be human. So the next time you hear about a NASA probe diving into Earth's deepest oceans, remember, it's not just a mission to the bottom of the sea. It's a voyage toward the stars, training on the only world we know to prepare us for all the ones we don't.